So where we left on the last, or where we left off at on the last video was identifying that the square root of 7 fell between the square root of 4 and 9. So since we know that the square root of those perfect squares, now we can figure out what two integers the number is in between them. So the square root of 4 is 2, and the square root of 9 is 3. So we know that 2 is less than the square root of 7, while the square root of 7 is less than the square root of 3. So ultimately, we know that the square root of 7 lies somewhere between 2 and 3. Well, again, looking back up here, we can see here that 7 is much closer to 9 than it is to 4, right? There's 3 digits between 4 and 7, while there's 2 digits between 7 and 9. So it's a little more than halfway to 9, or to 3. So I would say, and again, keep in mind, this is an estimate, but we know that it's closer to 3. And so we're just going to estimate to the 10th place. And so it's a little closer to 3. So I'm going to approximate it that it is going to be closer to 3, which means it's got to be greater than 2.5, but it's just on that other side of that halfway point between 4 and 9, so I'm going to say 2.6. Now, if you were to have done this problem, and if you would have given me 2.7 as an approximate, that would also be acceptable. So now let's look at example 3. So here for part A, we have the square root of 10. So we're going to estimate what irrational number the square root of 10 would be. So just like what we did with the square root of 7, we're going to do the same thing here. So we're going to look at our list of those perfect squares that the square root of 10 falls between. And so 10 is between the square root of 9 and the square root of 16, because we know that the square root of 9 is 3 and the square root of 16 is 4. So 10, it's much closer, I'm going to say a lot, closer to 9. So right here we can say that the square root of 9 is less than the square root of 10, which is less than the square root of 16. So now we're going to take the square root of those. Square root of 9, as we said before, is 3. And the square root of 16 is 4. So ultimately, right now, we know that the square root of 10 is between 3 and 4. So some value between 3 and 4 is what the square root of 10 would be. And keep in mind, this is an estimate, but when we look at it, 10 is real close to 9. Like we said, it's much closer to 9 than it is to 10. Therefore, we know that the square root of 10 is much closer to 3 than it is to 4. So as an estimate, which is why I show that, not an equal sign, but that's the approximate sign, because we're just making an estimate here, and that it's much closer to 3 than it is to 4, and because 10 is only 1 digit away from 9, while it's 6 digits away from 16, my approximate here is 3.2. Now, if you were to give me 3.1, that would be okay. It cannot be 3, though, because we know that 3 is the square root of 9. So our answer here for estimating what a rational number the square root of 10 would be, it is approximately 3.2. And now let's do the same with B, the square root of 35. So again, we're going to look at our list of our perfect squares. So in my list of perfect squares, I've got 25 and 36. So 25 and 36. Now right here, just looking at it, we can see that 35 is much closer to 36 than it is to 25. So now I'm going to write it out in terms of square roots. So the square root of 25 is less than the square root of 35, which is less than the square root of 36. So now we're going to find those square roots of 25 and 36. The square root of 25 is 5, and the square root of 36 is 6. So we know the square root of 35 lies somewhere between 5 and 6. And again, looking back at our original work here, 35 is much closer to 36 than it is to 25. So we know that the square root of 35 is much closer to 6 than it is to 5. And it's very close to 6. We can see that it's only 1 away. So the square root of 35 here is approximately, and I'm going to say 5.9 because it's very close. Now, just like I've been saying before, if you were to have given me 5.8, I would count that as acceptable. Because we are estimating here, while yes, there is a right answer, if you were to give me 5.8, 5.8 is also correct. So I want you to understand that there's not one right answer, but there is a right way to do this and a wrong way to do this, if that makes any sense. So let's continue moving on. Here we have our your turn. So we've got 2 questions here. So what I'd like you to do is pause the video, try these 2. So again, use that list of those perfect squares that we listed out to help you determine which 2 numbers the square root of 97 and the square root of 41 fall between. And then you can check your work with me. So the square root of 97, I'm going to use what I know, the square root of 81, or 81 is a perfect square, excuse me. And that's the next perfect square below 97. And then in my list of perfect squares, 100 is the next. So therefore 97 lies between 81 and 100. And both of those are perfect squares, which means I have an exact square root for them. So now I'm going to write this out in terms of square roots. And the square root of 81 is 9. And the square root of 100 is 10. So the square root of 97 is greater than 10, or excuse me, greater than 9, but less than 10. So it lies somewhere between 9 and 10. So again, this is where we look back at our original piece of work right here. I'm trying to draw an arrow here. And we can see that 97 is much closer to 100 than it is to 81. Therefore, the square root of 97 is closer to 10 than it is to 9. It's not too close, it's just 3 away. 97 is 3 digits away from 100. So I wouldn't exactly say it's super close to 10, but it's pretty close to 10. So in my estimate here, the square root of 97 is approximately 9.8. Now, if you gave me 9.7 or 9.9, right, one digit lesser and one digit greater, or 1/10 greater and 1/10 less, those would both be acceptable. So we just need our answers to be reasonable. And for 8, the square root of 41. So in my list of perfect squares, 41 lies between 36 and 49. So writing this out in terms of square roots, so the square root of 36 is 6. The square root of 49 is 7. So the square root of 41 lies between 6 and 7. And in my original work right up here, 41 is 5 digits away from 36, while it's 8 digits away from 49. So I would say that the square root of 41 is more closer to 6 than it is to 7. So the square root of 41 is, I would say it's just below that halfway point, right? 41 is almost in the middle between 36 and 49, but it's a little closer to 36. So I'm going to estimate 6.4. And now here, for example 4, we have x squared equals 225. So keep in mind, this was where we talked about in our video for example, or excuse me, in our video for page 4, so the page that we did just before this, we talked about how we can solve equations where we have x squared and x cubed, and we do that by taking the square root of both sides. So I'm going to take the square root of x squared and the square root of 225. So the square root of x squared is squared, or is x, excuse me, and the square root of 225. So this is where, looking at 225, I would use your notes and look at that list that we made, that we generated that list of the first 15 perfect squares. So I would look at that list to see, is 225 on that list? Because if it is, we know 225 is a perfect square. And if it's not, then that's when we know we need to approximate or make an estimate. And on my list of perfect squares, 225 is on there because the square root of 225 is 15. And one last thing to note here, we said that the square root of a perfect square, we have 2 square roots. We have a positive square root and a negative square root. So ultimately what that means here is that x could be positive 15 or negative 15. So we show that by writing x equals positive or negative 15. That tells us that we have 2 solutions for x. And so for b, here we have 64 equals y cubed, or y to the 3rd power. So to solve for y, in this case, we need to take the cubed root. So we're going to take the cubed root of both sides. So the cubed root of y to the third power is y, and the cubed root of 64, well, again, we can look at our list of perfect cubes, and we can see here that 64 is a perfect cube because 4 times 4 times 4 is 64. And in this case, it is just positive 4, because we know that there is only one positive cubed root for 64. So 4 is what y equals here. And then we have 2 more problems on this page. So now these two are just slightly different. Specifically looking at C, we have k squared equals 144 over 25. So because k is squared, we need to undo that by taking the square root of both sides. So the square root of k to the second power is k. And now we have to find the square root of 144 over 25. And when I look at both of those digits there, 144, I know that the square root of 144 is 12. And the square root of 25 is 5. And again, whenever we're finding the square root of something, we know that we have 2 possible solutions. So we write that by saying k is equal to positive or negative 12/5. And we could simplify that even further if we wanted to 2 2/5. But for right now, you can just leave it as an improper fraction. And then last one on this page, x squared equals 22. So again, we're looking at our list of perfect squares. And on that list, I don't see 22, which tells us that 22 is not a perfect square. So because it's not a perfect square, it doesn't mean that we can't do this problem. It simply means that we're going to have to estimate here. And we know that x will be irrational. So looking at my list, 22 falls between 16 as a perfect square and 25 as a perfect square. So now I'm going to go through those steps of estimating. So the square root of 16 is less than the square root of 22, which is less than the square root of 25. So the square root of 16 is 4. So we know 22, the square root of 22, lies between 4 and the square root of 25, which is 5. So now this is where we look at our original work. 22 is closer to 25 than it is to 16. It is 6 digits from 16, while it's only 3 digits from 25. So I would say that it is closer to 5 than it is to 4. So estimating it here, the square root of 22 is approximately, let's say 4.7. And again, as I've said before, if you were to have worked this out and you told me that the square root of 22 was approximately 4.6 or maybe 4.8, I would count those as correct. All right, so now moving on, I'm going to switch pages, so if you can flip pages in your notes, we're going to just round out lesson 14.1 here with just a few more problems. So here we have x to the third power equals 512. So x to the third power equals 512. So we need to take the cubed root of both sides. So the cubed root of both sides. So the cubed root of x cubed is x. And now we need to find the cubed root of 512. So this is where we can look at our list of those perfect cubes. And I know that I gave you the first 6 in that list, and I had asked that you continue on up through 10. And if you did, you will see that 512 is a perfect cube because the cubed root of 512 is 8. So x is equal to 8 here. Now number 10, c squared equals 196. So I'm going to take the square root of c squared and the square root of 196. The square root of c squared is c, and the square root of 196 is 14. And keep in mind, when we're finding the square root, we have both a positive and a negative square root. So c is equal to positive or negative 14, because 196 is a perfect square, and that is in your list. And number 11, we have m squared equals 9/49. So we're going to take the cube root of both sides. The cubed root of m squared is just m. And I know that 9 is a perfect square. And the square root of 9 is 3. And the square root of 49 is 7. So m is equal to positive or negative, because I'm finding a square root, positive or negative 3/7. And I'm just going to rewrite this here so you can see this clearly. And our last one here, a squared equals 70. So in looking at my list, 70 is not a perfect square. So I'm going to take the square root of both sides, although I know now that 70 is not a perfect square. So now I need to estimate here. So 70 lies between the perfect square of 64 and the perfect square 81. And the square root of 64 is 8. And the square root of 81 is 9. So the square root of 70 lies somewhere between 8 and 9. And 70 is 6 digits from 64, while it is 11 digits from 81. So 70 is much closer to 8 than it is to 9. So the square root of 70 is approximately 8.4 is what I will say. So here, a is equal to, and actually I'm not going to use equal to because I am estimating. And keep in mind, even though I'm estimating, it could still be positive or negative 8.4. Now, one last thing to add before you wrap up these notes in all of the problems where we were estimating the square root, I want you showing the steps just like I've shown you here, where I started out by just writing 64 as a perfect square, showing that 70 is greater than 64 as a perfect square, but less than the perfect square of 81. And then I took the square root of each of those. I wrote them as square roots, and then I found the square root of 64, and I found the square root of 81, and then I used estimation to determine whether the square root of 70 was closer to 8 or to 9. Okay? So, as I always tell you, if you have any questions, please don't hesitate to ask.